Okay, so today we're going to talk about significant figures, or sometimes people will call these significant digits. So it's just a way of reading a number. So you've been writing down numbers like 30 or 50.2, so people can tell what measurement you took plus what number you estimated. So the easiest rule, any non-zero number is significant. So if it says 54, it has 2. If it says 785.7, it has 4. Placeholding zeros are not significant, which means if you could get rid of them in scientific notation, we're not going to count them. So there's two types here, leading zeros, where 0.0 at the numbers. Sometimes they won't write that first zero, it's fine. But if you could cross out those numbers and just write it in scientific notation, we won't count those. So 0.0235 would have 3 sig figs. Trailing zeros without a decimal point would be 2500 would be an example. There's no number on here. So big numbers without a decimal number, ignore those zeros at the end. So that would have 2 sig figs. Sometimes they call this the Atlantic Pacific rule to cross out things on the sides like of the ocean. So a little harder rules. So zeros are the hardest for sure. Trapped or sandwiched zeros between numbers count. So 505. 5 and the two 5s are known for sure, but that 0 had to be measured. That means it was between 500 and 510. So that would count. 3 sig fig rules. So it's in the middle. So sandwich or trap zeros. Zeros after the decimal count. You wouldn't write them if you didn't need them. So these are ones that end up in the line. So 52 would be 2, but 52.0 would have 3. So if there's zeros after the decimal and the first number's not 0, on that, also treat those trap zeros. So again here, all these zeros at the end were actually measured, otherwise they wouldn't write them. So that other zero is on there, it's just exactly on 70. So all of those would count. 70.000 would have 5. So let's look at some more examples on here. So 2.35 or 23.50. The 0 is after a measured number on here, so this one is going to count, so that would be 4 sig figs. 402, this is a trap 0 right here, so it also counts, so that would be 3 sig figs. 5,280, there is no decimal point on here, so I can make this 5.28 times 10 to the third. We're not going to count that. Same thing here, I can make this 8.0 times 10 to the negative 2, so that would just have 2 sig figs. So there's going to be some rules on multiplication, division, and addition and subtraction. So what you want to do is keep the least accurate measurement, which means the least sig figs. So if I take 34.73, no zeros here, that's 4. 4.42 has 3, so my least of the two, 4 and 3, would be 3. My calculator would give me this long number. I would round that off. Now be careful, I do need to look at that 7 there and round up, so 78.86 grams per centimeters cubed. This is something called density. We're going to talk about this later this year, would be why you would take the grams over the centimeters cubed. The addition subtraction rule, it depends on your least accurate measurement. So if you're using different balances or people didn't write their numbers down, you've got to go by the one that's the least. So let's add up all these numbers. We have a whole number. We have a number with 1 decimal, one with 2 decimals. I'd add it all up like usual in my calculator. I'd round that off, and I can keep the least, which the least here is 0 decimals, so I'd have to round that off to 221. So again, I'm telling people I don't know this exact hundredth, I'm saying it's about 221. So I want you to practice these ones on here and then see how many they have. Pause this and then go ahead and go through and try this. Okay, so the first one, trap zeros, they all count 6. The next one, you're not going to count the 0 in the beginning, so that would have 3. You do count this one because it was measured after numbers. 500, there's no decimal point. That would be 5 times 10 squared, so 1. This next one, everything counts because we have a trap 0 and a 0 after non-zero numbers. This next one, you're going to cross out these beginning ones. This could just be 2 times 10 to the 0 power 1. And then anything in scientific notation before here would count, so this would just have 3. Here's some rounding practice. I want you to go through and practice rounding these to 2 sig figs, and again, make sure you're looking at the next number, so I'm just going to let you read through those. So let's go ahead and practice this one more time. So 2.89 times 4.01, you have a whole bunch of numbers here. You have 3 sig figs on both. Your rule says keep the least 3 sig figs, which would be 3. You're going to round this up here. Now you have to look, 11.58 means round it up to 11.6. Here's another one with different sig figs, 3 and 2. You get 107.26. You're only allowed to keep 2. You do have to be careful here. You'd have to round it to 110 on here. Another couple examples in here, so just go ahead and look through these.